All right, so on Friday, we had two things, right? Segment addition and definition of midpoint. So segment addition was we were taking two segments, adding them together to equal a whole thing, right? Okay, thank you. Midpoint means there was a point in the middle, and it took the two segments and made them what? Equal. All right. Now, so on this one, if we know it's segment addition, here are some key things that would tell you it's segment addition. Is M in the middle? All right, so let's do this. How would we know it's in the middle? Tick marks, or they could say what word? B is or M is a midpoint, right? Since neither one of those, we know it's not in the middle. But they did give you LN, which is the whole thing, right? Okay, so your first statement. Now you've got the right idea if you didn't do this first, but you need to do this first going forward. So what I mean by that is my first statement is going to use the letters because that's the geometry part. So I'm going to write LM plus MN. That's my two segments. So I'm not going to start with the 5x minus 6 in the other part. You guys with me? I'm going to start with LM and MN. Then I'm going to put it equal to LN, which is the whole thing. Okay, is everybody with me right there? All right, so look at this. So Tony, look at this part. LN is the whole thing, right? You with me? So I'm using the letters. So ignore the 5x minus 6, those. So from L to N is the whole thing. So that's what the whole thing equals. That's here. My two parts is this part, right? And that part, that's what I'm writing there. And then my reason, okay, is when we said the first thing, what type is this? We said segment addition, right? That's the reason. We know it's a segment addition problem. Everybody good there so far? Now the variables will go in when we do, what's it called? What is it called when we plug in for those? Substitution. So we're going to substitute in what they're equal. So LM is 5x minus 6, right? So that's me plugging in for that part right there. MN is 3x minus 4. And then LN over here is 18. And our reason is substitution. Okay, so let's pause for a second. Because basically all of the ones we're going to do the next couple days, or today, because that is 2 days, they're going to look like this. But we just have to decide how to set them up. So as of right now, we have segment addition. And if I'm using segment addition, it's always going to be part plus part equals the whole thing, right? If it's a midpoint, what's it going to look like? Is there going to be 3 parts or just 2? 2, because you're going to say this part equals that part, right? Does that make sense to everybody? Because that midpoint's in the middle. Good thing is today when we do angle, we're going to do angles. But the concept is the same. We're just doing it with angles. And then everything else on all these problems is going to look exactly the same. You're just doing algebra. Depends on how it's set up. So like here, we have to combine like terms first, don't we? 5x and 3x or 8x. Negative 6 and negative 4 give me negative 10. I'd add 10 to that side, right? And then I would divide by 8. I'm going to put it like that right this second because it's a decimal. I did write all my numbers down correct, didn't I? Okay. So we got a decimal, which could happen. Which that simplifies into, let's see, what, 14. Was it 3.5? Thank you. Okay, can anybody think of a question on that one? Because if you have a question on this one, it's probably going to relate to what we're going to learn today. So it would be a good time to ask it. Another thing that I need to make sure I point out, and I don't remember what it said, to be honest. I found X, right? What did it want us to find? What's it say up there? Complete the proof. Does it say find anything in particular? Does it say find X, or does it say find LN or MN or anything? All right, so it said find the value of X. Did we do that? Because they could throw in there, it'd be the same problem, but instead of saying find the value of X, they might say find LM. What would that tell you to do? We know X is 3.5, right? So if I go up here, what's LM? It's 5X minus 6, isn't it? That would just tell you how to do one more step. I just need to take the 5X minus 6 and plug the 3.5 in there. You guys with me on that? This one, we didn't have to do that because why? It said find X. It didn't say find one of the other parts. Okay, everybody good with that? Okay, so now today we're going to do that same exact thing with angles. Okay, so look at the first little thing underneath there. See where it says find the measure of dBA. So let's do this first because I know sometimes it gets confusing. Let's remember when we're naming angles what things mean. So if it says find I want to make sure we all know what angle dBA looks like. When I have three letters, the middle letter will always be the what? Vertex. The middle letter is always the vertex. So when I go to this big triangle here, B right there, that's my vertex. Look at my other 2 points, D and A, right? So A is out here, isn't it? So that's one side. That's that ray. D is over there, isn't it? So we're really talking about the entire thing, aren't we? Now, all this problem is doing is it told you what DBC was equal to, didn't it? What's DBC equal to? Is it 34? So that means that this angle is 34, isn't it? This angle, isn't it 45? Okay, so they gave us a number for the two angles just so we can see how this works. So does it make sense to everybody that if this one's 34 and that one's 45, 79 would be the measure of angle DBA, wouldn't it? Okay, now here's what I want you guys to do, just so you can see this. You may have just wrote down 79, but I want you to write 34 plus 45 equals 79, where you have a little bit of space below it. The reason I'm having you do that is I want us to see this next part. So you guys agree that 34 degrees was DBC, right? So what that means is this is angle DBC. Write that under the 34. If you didn't have space, if you put it over it, that'd be okay too. Do you guys agree that 45 is CBA? That's my 45. So what we're saying right now is angle DBC plus angle CBA. What should I put for the equals? DBA. Same thing we just did with the segment addition, except now we're doing it with angles. And you're never going to guess what they're going to call this. Angle addition. So this, that next part I think says that. We're going to go over that. This is angle addition. Now you can put postulate after, it's a fancy word, but you do not have to put that part. All right, so where it says angle addition postulate, if point B is the interior of AOC, then the measure of, what should we put in that first blank? Looking for an answer here. Is everybody in the box looking? AOB. Does everybody see where the, look at the AOB, where it'd be in the picture. That's one angle, isn't it? One part. plus what would be our other angle, BOC, and it would equal AOC. That's an angle addition statement. All right, so you guys tried number 3. There's 3 parts, A, B, and C. Do that. Draw it in. Do what it's saying. Okay, so what you wanted to do, put a point. Now they're just talking about in between. Does it mean it's right in the middle? If you put yours down here, up there, that doesn't matter. Anywhere in here, okay? I drew this line in, which is a ray because it starts here and goes that way. So this one right here would be NMD. Now, what else could I put there that would still be correct? How else could I have named it? DMN would have still been right, as long as M is in the middle because that's the vertex. This one is that one right there, DML. If you would have put LMD, that still would have been right. And then last, you got the NML, which is the big one. So this right here is an angle addition statement. Does that make sense, everybody? All right, now we're going to do a problem, what it'll look like together. Good. So go down to the next part. All right, you guys see this picture they've got there with this angle XYZ? You guys with me on that? All right, XYZ is the big part, isn't it? So when we start this, okay, we're going to have these statements and reasons, right? The first thing we're going to put is the measure of angle XYJ. So let's make sure we see what we're doing there. XYJ is that part, isn't it? Plus angle JYZ. The benefit of being dry erase, I'll just move that thing over there. Equals XYZ. So does everybody see where I got that from? That's an angle addition statement. So the reason that we'll put beside it is angle addition. And then now this is where I was talking about it will be just like the problems we've been, all of the ones will be the same. Once I get this part set up, I look up here and see what they give me for each one of those. What is XYJ equal to? 5x minus 7, so I'll substitute that in. I'll look up there. I'll see what JYZ is equal to. It's x minus 10. And then I'll look up here to see what they gave me for XYZ, which was 118. And I have now done substitution. I've plugged in what each part was equal to. Now I'm going to do algebra. Combine like terms. We add. And we divide. Whatever that is at 135 over 6. 22.5. Okay. Let me pause for a second. Does everybody, that make sense to everybody? Or can you think of a question right now? Because we want to check one more thing. Yep, the only other thing that we can mess up is to make sure this said find x, right? So boom, that's our answer. If it would have said find one of the measures of the angle, we'd had to plug that in. Okay, so hopefully you guys can see how that's exactly what we did on the other stuff, just with angles. And then now we're going to turn the page and we're going to do the exact thing we did with midpoint, but it's going to be called a bisector. The only difference in a midpoint and a bisector is a line, ray, segment that cuts something in half, as opposed to a midpoint is the point on it. Okay, so we're going to put in here, bisectors will cut something into 2 equal parts. Two equal parts. So a bisector is going to take another segment or something and slice it into 2 equal parts. So this bisector, a segment bisector, can be a ray, a line, a segment, whatever, any of those. Now I'm down in that next box that intersects a segment at its. So if a bisector is going to cut a segment in half, what does it have to go through? It has to go through the midpoint, doesn't it? That's why it works out the same as the midpoint problems we're going to do. Now, not to get too fancy, but if it's an angle bisector, what do you think it's cutting in half? An angle. An angle bisector is a, so look at that picture. What would you call CB? A ray. Yep. An angle bisector is a ray that divides the angle into 2 congruent angles. So in that box, we would put the measure of angle ACD is equal to the measure of angle BCD or DCB, either way. Okay, so let's look at an example. Okay, so first off, let me ask you a question. Looking at this picture, I left off something they had on there, sorry. What would tell me that I know that this right here is a bisector from the picture? See the tick marks? That means you know they're equal. So therefore, this is going to work just like the midpoint problems. Our first thing that, now, I'm time out, sorry. You guys see how they have given up there and they got some blanks? All right, in a proof, you always put down what's given. Sometimes it's written. You guys are just filling in what they already told you. So on step 1, on this one, this says Pn is the, what should we put there? Bisector of JL at K. JK equals 6x plus 7, and KL equals 4x plus 5. And our reason for that is going to be given. Okay, because that's what they told you. Going forward, if they have all of that written out, where you would have to write all that in, if you put the word given there, I'll take that. Does that make sense? Basically, anything they tell you at the start, That's called the given. Yeah, whose is it? Again, it's not, in case you're wondering. So we got given and given. Does that make sense, everybody? All right, so we have some real life video going on here. So if you're at home, make sure that your phone's on silent. Don't be messing us up when you're watching this.
It says it's on silent.
I'm not a rocket scientist, but I know it's vibrating. That's all I know. Now, if you're gonna ask me how to put it on something else, I have no idea. All I know is, hey, and I do know this. Next time, maybe sit on that couch so if it does vibrate, it's not as loud. How about that? Once again, I know some things, not a lot, but I do know that. All right. So, what do you guys think we're gonna put for our second step here? Anybody know? I'm hoping somebody does. Yep, we're gonna say JK equals KL. Because that's the two parts that are equal, isn't it? Now, the only thing that's different about the midpoint, they didn't tell us midpoint. They told us that it's a bisector this time, right? So what do you think we write for a reason? Yep. I'm going to put segment bisector. Now, the only reason I'm putting segment bisector is so that we understand the difference later. There'll also be an angle bisector. Does that make sense? So this is a segment bisector because it's cutting a segment in two as opposed to an angle bisector. And now the awesome thing is the rest of it's going to be just like we've been doing, isn't it? We're going to take and see what's JK equal to. 6x plus 7. We're going to substitute it in, aren't we? We're going to look up there, see what KL is equal to. We're going to substitute that in. By substitution. Then I'm going to subtract. Now, once again, this is one of those, you could do this all in one step because they're both going to be subtract. But it's up to, if you do two steps, that's fine. But I'm going to subtract the 4, and I'm going to subtract the 7. These are both subtraction. So if you did that all at once, that would have been legal because they both had the same reason. And then we're still going to divide at the end, right? Oops, sorry. 5 minus 7 is negative 2. We divide by 2, and we get negative 1. And we've done that one. Okay, everybody good on that one? I did my math right, didn't I? All right, so this last part, all we're going to do right now is on 6 and 7, you're not going to work it out. But this is, once again, an example of either angle addition or it's an example of a bisector type. Does that make sense? So you're going to write the first step down. So let's do that for 6 and 7.